A very good afternoon to all of you. So today we are going to start our new topic, that is cycloconverter. So basically this cycloconverter is a power electronic device and it is used to vary the frequency. Now, as you can see that the cycloconverter can increase or decrease the frequency of a supply. The frequency of a supply is normally a 50 hertz supply. So you can increase or decrease the frequency, and this will be quite useful for VFDs because in the VFD you need to vary the frequency. So for that you will have to go for this cycloconverter. So now, as I told you that this cycloconverter can be classified into two types. The first one is the step up and the second one is the step down cycloconverter. So we will be studying this bridge type cycloconverter. So first, this is a single phase. A single phase cycloconverter, single phase to single phase conversion is there. The voltage will remain constant, but the frequency is going to change. Now, suppose if you want to change the frequency, what does it mean? It means that suppose if you want to increase the frequency, then in that case you will have to decrease the time period. And if you want to decrease the frequency, then in that case you will have to increase the time period. It is a reciprocal, they are having the inverse relationship, we can say. Now, this is the cycloconverter. Now, this one is the positive group. As you know, this is a bridge type version, and again this is the negative group. So they are but it looks like they are in the anti-parallel connection, they are in the anti-parallel form. So these are the two, there are four SCRs, that is P1, P2, P3 and P4. P1, P2, P3 and P4. Now similarly you will be having this negative group of the SCR. Now this will be, now you can see the supply is given to both the converters. So this is the positive group of converter and this one is the negative group of converter, and this supply is given to both the converters. So you can see that we have assumed the current as the source current as IS, and it has got the two component. The first one is the positive group of positive component and the second one is the negative component. So we'll denote it by IN. So now how to increase or decrease the frequency? Now I think we'll draw the waveform first. Now you can see that this input voltage will be having the sinusoidal nature. It will be having the two halves. The first one, this is the positive half, and the negative half. Now you can see that this will start from omega t will be equals to 0. Then it is going to reach to the peak value at omega t will be equals to pi by 2. Then this one is pi, and you are having this 3 pi by 2, and this one is 2 pi. So we have taken only the one cycle of the supply. So now this is fed to these converters. Now what is going to happen? You see that when during a positive half, this point will become positive and this one will become, you can see here, this is positive, so it will be going here, and this one is negative. So what is going to happen? This A point will be more positive as compared to the B point, and similarly you can see here this point is more positive as compared to this point. So which two thyristors will on? So during a positive half, what we can write? During a positive half, we can write that P1 and P2 are going to be operating, because you can see that only this P1 and P2 are in the forward bias condition, whereas this P3 and P4 are in the reverse bias condition during the positive half. Fine. Now, similarly, you can see here N1 and N2, they are in the forward bias condition, or you can say they are in the forward blocking condition. And the remaining two SCRs, they are in the reverse bias condition. So they are not going to be turned on during the positive half. Now, similarly, you can scratch it just like this. So P1, P2 and N1, N2. So P1, P2 and N1, N2. So what we can say that from the positive group, you can have two SCRs operating. The first one, that is P1, P2, and this is the second group, that is N1, N2. Now similarly, what is going to happen? Now similarly, during a negative half, what is going to happen? This one will be more negative, this one will be more negative as compared to the lower half. So this negative will come here, negative will come here, and positive will come here. So again you can see here, this negative will come here and this positive will come here. So what is going to happen? You can see here the now during the negative half, the N3 and N4 will be forward biased. So we can write here, during a negative half, during a negative half, this P1, this P3 and P4, P3 and P4 and N3 and N4 will be operating. So in this way, you will have to understand the operation. So now this is clear to you. That is, during a positive half, the P1, P2 from the positive group and N1, N2 from the negative group will conduct. And during a negative half, this P3, P4 and N3, N4 will be operating. So I think this much is clear to you. So now we'll start the things. Now you can see here, now we'll draw the output voltage waveform. So output voltage will be like that only. So we can, right, we will draw the envelopes of it. So how to draw the envelope? You can see here, this one is the omega t. Now this is one half. This is supply frequency, and you have to increase the supply frequency because we are studying step up cycloconverter. It means that the output frequency will be higher than the supply frequency, or in other words, the time period of the output signal will be lesser as compared to the input period of the supply. So in this case, this is output voltage. Now we will draw the envelopes we will have to draw. So this is, one is the positive envelope. This is the positive envelope, you can see here. This is the positive envelope, and this one is the negative envelope. Fine. This is, I think this much is clear to you. So now how to start with this? So we'll take the right. We'll take the black color, right? So you can see here, so during a positive half, so this one is positive and this one is negative. So like I mentioned here, so suppose again this is positive and this one is negative. So how will the current flow? So suppose if you are, now these are in the forward blocking condition. You can see here, this P3 and P4 will not conduct, but this P1 will conduct. Now similarly, this N3, and so we will again put a cross on these SCRs. So how it will conduct? The current will flow from this. Suppose if you are giving a pulse to this positive group. Suppose if you are giving a pulse to the positive group, so what is going to happen? You can see here, the current will flow from the supply voltage, then the current will enter in this node, then this P1, because you have applied a gate pulse to it. Now when you are applying a gate pulse to the SCR, it means that your SCR will start conducting. You can use GTO also, you can use MOSFET also, it is up to you. Now suppose this P1 will be conducting, so the current will flow through this. Now you can see here, this terminal, that is X and Y. So X will be more positive, so V0 will be directly applied. V0 will be directly applied to this positive terminal, and Y will be directly applied to this negative terminal. You can see here the current is flowing in this fashion. This P1, then you are having a load, and this, so in this way you can see. Now suppose if you are not giving a pulse to this positive group, and if someone wanted to give a pulse to what you can say, this N1, N2, so how it will operate? You know, now you can see here, this one, the current will flow from the source, then this point will occur. So you can see here, now N1, you can see that the current is flowing in the downward direction. The current is, you can see the current is flowing, the current has entered this node, then it is flowing the downward direction. And now you can see, so what you can see, that the positive will be applied to the Y point. So when you are giving a pulse to the negative group of SCR, it means that you will have to follow the negative envelope. during the positive half. But I'm saying that during a positive half, only this will operate. So you will have to play with this P1 and P2 and N1 and N2. Is it okay to you? And during the negative half, you will have to play with this P3 and P4 and N3 and N4. But what I'm saying that if you are giving a gate pulse to this positive group of SCR and to negative group of SCR, so for positive group, you will have to follow the positive envelope, and for negative group, you will have to follow the negative envelope. Fine. So in this way, you will have to do this. Now, similarly, during a negative half, the same thing is going to repeat. Suppose if you want a positive envelope, then give a pulse to P3 and P4. And if you want a negative envelope, then you will have to give a gate pulse to the N3 and N4. So I think what we will do, so we'll just give a gate pulse to, we will just give a gate pulse to P1 and P2. So what is going to happen? You will have to go at omega t will be equal to 0. Now suppose what I'm saying that at omega t will be equal to 0, you are giving a gate pulse to the P1 and P2. So this is so this you can see, this you can find, this is the positive envelope, because the load voltage is going to follow the nature of the supply voltage, and right now the nature is this only. Fine. Now now at this point you will forcefully commutate your P1 and P2, and forcefully you will have to commutate. In this step up cycloconverter, you will have to go for the force commutation, and in the step down cycloconverter, the natural commutation will be applicable. Now you will commutate, or you can say that is you will have to turn off this SCR forcefully. Now you apply the gate pulse to N1 and N2. Fine, N1 and N2. Only these will operate. So when you are giving a gate pulse to N1 and N2, so you will see here, you will in this fashion. This is so during this period, P1, P2 will operate, and during this period, N1, N2 will operate. Now similarly, again at this point, you will forcefully commutate. So again, this will follow the positive envelope because P1 and P2 will come into the action. So this one you can see here. Now again, this is P1 and P2. Fine. And this is N1 and N2. So at this point, you can see this is omega T1. So I think we'll come here and we'll try to understand, because I have already drawn the waveform for you people. So you can see here, I'll remove this for better understanding. Okay, so you can see that during the positive half, P1 and P2 and N1 and N2 is going to operate. So at omega t will be equal to 0, you are giving gate pulse, you are giving gate pulse to, okay, you are giving gate pulse to P1 and P2. So what is going to happen? V0 will be is directly connected to the source voltage, and it is going to follow the nature of source voltage. So this is the period. You can see P1 and P2. And now at omega t will be equals to omega t1. You are forcefully commutating your thyristors P1 and P2, and at the same time, simultaneously, you are giving gate pulse to the N1 and N2. So this is going to follow the negative envelope. Now again, at this point, omega t will be equals to omega t2. You are giving gate pulse to this P1, P2. Again, at this point, you are giving gate pulse. So whenever you are giving gate pulse to, so it is switching between the envelope. It is switching between the positive and the negative envelope. So in this way, you will have to go with this, you can say half cycle. Now when you are right. So when you are coming into the negative half of your supply voltage, so that time N3, N4 and P3, P4. Fine. During negative half of supply voltage, only this P3, P4 and N3, N4 will operate. So you can see here, if you want a positive envelope, again you are giving gate pulse to the, you can see P3, P4. Now at this, you are forcefully commutating this P3 and P4. Now again N3 and N4, again P3 and P4. So in this way, you can get the output voltage. Now So whether our frequency has stepped up or not, we will have to check it out. You can see this is the supply voltage. This is supply voltage. So TS will be equals to 1 upon FA, that is the supply frequency. Now what is the output frequency? Output frequency will be only this one. You can see output frequency, that is this one. This is the output frequency. Just a minute. This is the, if you take only the one half, because you will have to take only the one half of that. So we have taken, so output frequency will be from this point to this point. This is the output frequency. So you can see here for one cycle, how many cycles you are getting, how many output cycles you are getting. You can see this is from this to this point, that is one. Then this is two. Then this is 3, this one is 4, this one is 5, this one is 6. So we can say that these six cycles of output frequency, the 6 cycles of output frequency have been obtained for the one cycle of the supply voltage. So the output frequency will be F0. F0 will be equals to 6 times Fs. Fine. So in this way, you can step up the frequency. And suppose if the frequency is 6 into, this is supply frequency, that is 50 hertz, because we are living in India. So around 300 hertz you can obtain by using this step up cycloconverter. Now, what about the step down cycloconverter? This step down cycloconverter. So, in this step down cycloconverter, it means that the output frequency should be less than your supply frequency. Fine. So, this is your right. So, this one is your supply frequency. I'll draw some waveform. Okay. This is the supply frequency, that is 50 hertz. And okay. Right. So this is omega t. This one is omega t. This is supply frequency. I will change the color to understand the concept in a much more efficient manner. So, right. Now, what is going to happen? Now we have taken the load as resistive, not as inductive load. We have taken. Fine. But when you are applying the cycloconverter to the induction motor, so that time I think you will have to take care of all these things. So fine. So now, right now, for simplicity and for making the concept more precise and more simpler, I have taken the resistive load, not the resistor and inductive load. I have also taken into account RL load. If you want to understand more, then I will provide a video on that also. Fine. So now you can see here the step down cycloconverter. It means that the output frequency should be lesser as compared to the supply of frequency. So fine. Output frequency is less means time period is high. Fine. So what is going to happen now? You can see here during this half. Okay, I'll draw the negative envelope also, because if we want, we will draw here only. We will draw the output voltage here only. This is a simple single phase conversion, but in the examination, you will be encountering the three phase to single phase or three phase to three phase conversion. Fine. So at omega t will be equals to, this is omega 0, this is pi, this one is 2 pi, this one is 3 pi, and 4 pi, and right, I'm not able to draw the this is one is 5 pi, and this one is 6 pi. So basically, how to start with this? So at omega t will be equal to 0, you will have to give the gate pulse to P1 and P2. Fine. So when you are giving the gate pulse to P1 and P2, so what is going to happen? You will be getting the positive envelope. You are going to get the positive envelope. Fine. Now again, at omega t will be equal to pi, you don't have to give to the have to give the gate pulse to N3 and N4. Again, you provide the gate pulse to P3 and P4. Fine. So this one is P3 and P4. This one is P3 and P4. Fine. Now again, you apply the gate pulse to what? Here you are giving the gate pulse to P1, P2. Then this is P3, P4. This one is P1, P2. And so now here, this one is N3, N4. So this one is N3, N4. Now you can see here, this one is, we are drawing the source supply voltage to make okay. I think I have not drawn the proper supply voltage. Just give me a moment. Okay, because I think right. Okay, uh, that is this one is okay. This one is okay. This one is right. So during a positive half, this P1, P2, N1, N2. During negative half, this P3, P4, N3, N4. During a positive half, P1, P2, and P1, P2, N1, N2. Negative half, P1, P3, P4, N3, N4. So what I am doing that, I am not triggering the negative half immediately, negative group immediately. What I am triggering only the positive group of SCR for three half cycle. Now you can see for three half cycle, this positive group of the SCRs are conducting, and for the remaining three half cycle, the negative group of are conducting. So you can see here, this one is N3, N4, then N1, N2. So you are going to get the waveform like this. You can see here, you are going to get the waveform like this. So this is the waveform. So I think if you just filter out this waveform, you are going to get the sine waveform. Understood? So what I have done that the output frequency, you can see output frequency has lowered. Initially, you can see the frequency, I think it has lowered to F0 will be equals to 1 upon 3 into Fs. 1 upon 3 into Fs. Fine, because we are not, conducting N1, N2 immediately, or you can say N3, N4 immediately. We are delaying that thing. Fine. So when you are delaying it, that means what? You are reducing the output frequency. So now in this case, your output frequency will be equals to F0 is equals to 1 upon 3 Fs. Your input, your supply frequency is this much only, but you are delaying by three cycles, no? So in this way you can obtain the output frequency for the step down cycloconverter. So I think this much is very clear to you. So in the next video, we'll try to understand the three phase to single phase, and that is the important point, and that is the point of contention, we can say. So this is all about for this video. Tomorrow or in the next video, we'll try to understand that. Thanks a lot.